Hey all, my name is Uday. I am a tech lead and a principal software engineer at Oracle. My background and experience is in e-commerce platforms, search engines, information retrieval, machine learning, and distributed systems. In addition, I am part of the AI Advisory Council at CompTIA. CompTIA stands for Computing Technology Industry Associations. So at CompTIA, together with my fellow AI Council members, I help strategize and build technical resources and guidelines related to building enterprise-grade artificial intelligence and machine learning solutions. I am also an editor at InfoQ, where I write news pieces, technical deep dives, and tech articles on AI, ML, DevOps, and programming languages like Java and JavaScript. So before we begin, let me get the safe harbor statement out of the way. I want to emphatically state that the views expressed here, which tend to be opinionated, are my own and not those of Oracle or any other companies. You know the drill. Okay, on to the fun stuff. Here's the agenda for the presentation. I am going to start with a brief refresher on conversational AI. I am then going to talk about a brand new breed of user interfaces, or rather supercharging existing user interface designs. I asked myself the question, what if we supercharge the well-known command line and graphical user interfaces with conversational AI? How would they look like? What would be the advantages of doing this? So I'm going to talk about these things, and I will do a walkthrough of building these supercharged interfaces using Rasa. As most of you know, Rasa is a machine learning-based platform that allows us to build conversational AI systems. And so in this talk, you will also see how one can integrate Rasa with traditional CLIs and graphical interfaces, and in the process, hopefully provide an enhanced user experience. So what is conversational AI? Let's take a look at some examples here. Now we are familiar with Alexa, Siri, and OK Google, right? In fact, it is pretty evident that these digital voice assistants are becoming ubiquitous in households these days. And interactions with these assistants are examples of AI-driven conversations. You may also be familiar with things like FAQ bots, what I tend to call infobots, and other kinds of chatbots, like, for instance, a COVID-19 symptom checker. Now, these are also examples of AI-driven conversations. So in essence, conversational AI refers to the use of artificial intelligence, more so natural language processing with machine learning, and the ability of these systems to naturally engage in conversations, naturally engage in dialogues with humans. And this could be done via voice or through text, or it could be a combination of both voice and text interfaces. Now, a brief history here. The first generation of assistants, the chatbots, were mostly rule-based. When I say first generation, these chatbots were built, 4 years ago, maybe at least a couple of years ago. And since these were rule-based, they were kind of brittle, and as a result, were unable to hold natural conversations with users, which, as we know, can tend to be very messy. And so it's no surprise that some of these chatbots fail to meet user expectations. But with the recent advancements in natural language processing, the second generation of assistants are much more capable in terms of understanding the nuances of natural language, the context of a conversation, and the ability to naturally talk to humans and also perform actions on their behalf. So it's no surprise that these second-gen conversational AI systems are being able to provide better customer support for sales, for services, to provide better citizen experience. For instance, providing factual and authoritative information regarding COVID-19, the unfortunate current pandemic we are in. So now let's briefly look at the underpinnings of conversational AI, namely NLP and machine learning. When I think of natural language processing, I think of it as a field of linguistics, computer science, and artificial intelligence. It deals with the processing, the extraction, and it also deals with the analysis of text. It could be unstructured data as well, but basically all these things in a given human spoken language like English or Sanskrit. And no doubt it's an enormous field. Things like speech recognition, speech synthesis, machine translation, natural language understanding, and language generation. These are all the various subdomains of NLP. But then there are two subsets under NLP that keep coming up when we talk about conversational AI, that is NLU and NLG. Natural language understanding, NLU, it deals with the system's reading comprehension abilities, aspects like, for instance, text classification, for automatic analysis of articles, blogs, news pieces, and also sentiment analysis of this data, extracting key pieces of information from both structured and unstructured data, like entity extraction. These are all things that fall under NLU. And as far as NLG, natural language generation, is concerned, it deals with the ability of a system to auto-generate text based on context, a topic, or a conversation. NLG is still in its infancy, and I think we will continue to see more cutting-edge research in this field for sure. Anyway, so all these latest advancements in NLP, in machine learning, in deep neural networks in general, these are all making it possible for us to build better conversational AI systems. When I keep saying advancements, right? These include things like, for instance, moving from the context-free word to vec and glove word embeddings to much more advanced bidirectional contextual models. The enhanced convolutional neural network models, the introduction of attention-based neural networks, transformer-based language models, the concept of transfer learning, and all of these are the advancements that I'm referring to. A quick note on BERT and GPT, bidirectional encoder representation from transformers, BERT. This is from Google. It was released in 2018. It is a transformer-based learning for NLP. It's also a pre-trained language model on a large corpus, and it can also be fine-tuned on specific NLP tasks, for instance, like fine-tune it to do entity extraction and achieve better, higher accuracy scores. So that's BERT. Similarly, GPT-2, generative pre-trained transformer. Now there's GPT-3 as well. These are from OpenAI. GPT-2 is a large self-supervised transformer-based language model. It can definitely be used for machine comprehension and text generation, right? And I believe it was also trained on a large corpus. The data set was about 8 million web pages. Anyway, as you can imagine, all these advancements used for the right purposes will help us create conversational AI, good conversational AI systems, and provide better user experiences. Okay, now let's see if we can leverage conversational AI to enhance the age-old command line and the well-known graphical user interfaces. Now, I believe we can supercharge these interfaces with conversational AI. And what I mean by that is we can build and design user interfaces where the conversational AI sits at the core, like it's the core engine. And before we dig deeper, I initially thought that we should call this new breed of interfaces as Instructional Dialog Interfaces, IDI. It did make sense to me to call them as Instructional Design Interfaces, but now I'm not entirely convinced. If you think that the name makes sense, spread the word. If not, and I think that will be the likely case, I am open to suggestions from you. Anyway, so let's talk about how we can supercharge these interfaces and how we go about doing that. So let's start with the command line interfaces. We all know CLIs, these are the traditional interfaces for humans to interact with computers. They're always mostly small, succinct, and have a strict syntax. And believe it or not, they're kind of conversational in nature. Some CLIs, for example, do pose a series of questions to the user. They can interact using a terminal, and they gather the information before executing a command, for instance. And CLIs, they do come up with help manual of sorts, and in order to give user hints on how to effectively use a CLI. Now, what would it look like if we redesign CLIs with conversational AI at the core? Of course, it's a matter of personal choice when it comes to using traditional CLIs. The traditional commands, CLIs, are very succinct. They definitely do the job really well. That is one of the Unix philosophy, right? Be small and do one thing right. Uh, but sometimes these CLIs, they tend to be complicated in terms of using options and how they are structured. And so I believe we can provide better user experience if we build CLIs powered by conversational AI. So for example, the find CLI with conversational AI would allow one to type something like, find me all JSON files sitting on the sandbox created after June 10th, or find me all the files under the source folder that contain the word NLP. So as you can see, doing so provides us with a few advantages. The obvious thing that is that it enhances the user experience since we can use natural text. Definitely expedites the onboarding process in terms of the user being able to effectively use the CLI, and it also decreases the need for command line cheat sheets. I mean, we all do use command. I mean, I do use command line cheat sheets when I'm dealing with complicated CLIs like kube control. Okay. Now that we know what it means to supercharge a command line interface, let me walk you through the steps that we can take in order to build these supercharged CLIs. So here's my solution at a high level. We're going to use YAML to define the CLI. We're then going to use Rasa for the conversational AI aspects of it. That's our core engine of the CLI. In order to do so, we're going to leverage the REST APIs provided by Rasa, and we can also enhance the CLI engine to provide its own set of REST APIs sitting on top of Rasa's REST APIs. It all depends on the needs of the CLI. And then actually implement the CLI in a specific programming language based on the YAML that we define, and that programming language could be Java, Rust, Python, whatever, right? Okay. Actually, now is a good time to take a brief detour and discuss Rasa. As I mentioned before, Rasa is an open source machine learning powered framework that lets us build conversational AI systems. So one thing you can do with Rasa is you can describe the intents, the entities, and provide training data to build your NLP model for a given specific task, or in our case, the CLI. And an intent, actually, in simple terms, is something that a user is trying to accomplish, or the intention behind the user's query or statement. So the job of the NLP model is to classify a given utterance into one of those defined intents that we tell Rasa to identify. Now, entity extraction, that is the process of identifying keywords that carry additional information related to an intent. For example, in the utterance, find all JSON files under sandbox created after June 10th, we can easily say that there are quite a few entities here. One could be the folder sandbox. The other one could be the file type JSON, and one more entity would be the date June 10th. So entities can be extracted using various methodologies. One could be regular expressions, but obviously using Rasa, we can do more sophisticated NLP techniques like named entity recognition and things of that nature. Now, Rasa also provides us a machine learning powered dialogue management system. So we can actually build truly conversational AI systems. What I mean by that is we can enable multi-turn, context-aware dialogues without always having to use hard-coded rules, but be able to use machine learning to predict the dialogue flow. Okay, so with that in mind, let's design or rather redesign the famous Cube Control CLI uh, using Rasa. So most of you might know this. Cube Control CLI is used to control and manage a Kubernetes cluster. It's extremely powerful and also as a result fairly complex. It has multiple commands, subcommands, options, flags, some global, some specific, and so on. I remember when I initially started using Kubernetes and kubectl, I had to really rely on cheat sheets and help manuals to get things done. uh, Actually, this is the initial phase of using a CLI that I call onboarding. Okay, so the first step in our redesign of kubectl is to, like I said, one solution is to use this YAML spec, a YAML syntax. It's pretty straightforward here. As you can see, we can define the available commands, subcommands, help text, options, and so on. Now, the reason I'm proposing the usage of a YAML file is that that will make the implementation easier. I mean, you can pick the language of choice, but you can still use a single uh, spec YAML file to define what your CLI would actually do. Like, for instance, the Swagger REST API, that's the spec, and your implementation, you can do it in Java, .NET, Python, whatever, right? So anyway, like I said, it's pretty straightforward. You define your available commands, subcommands, and things like that. And then the next thing will be for us to use Rasa's NLP component to convert the commands and the subcommands that we defined in the previous step into intents. Now, as you can see, the CLI options can be defined in Rasa as entities. Now, again, note that this is a Rasa-specific YAML file. It's called a domain file, wherein you can list the intent names, entity names, and things like that that are specific to your project, to your CLI. Again, pretty straightforward. Okay, next, let's give Rasa some examples, like the training data for all the intents that we just listed. So for each intent, we provide a few examples so the NLP model can learn to identify the intents and any entities specific to our CLI. Again, this syntax is a YAML file that's supported by Rasa. It's a training data YAML file. Pretty straightforward. You provide some examples for each intent, and sometimes you'll also be able to say, okay, also identify this specific word as an entity that corresponds to something that I just defined in the domain file. All right. So finally, we will provide Rasa some sample conversations. Again, training data in Rasa speak. These are called stories. There are also rules. Anyway, so here we are providing simple conversations that, for instance, say, hey, if the user's intent is identified as a show config, then trigger the action named action show config. Similarly, if the user's intent is identified as current context, then trigger the action named action current context. Now, of course, Rasa allows us to provide more complex conversations, even collect real user data, so that we can better train the model where the user gets distracted and asks for something else in the middle of conversation, comes back, all the context switching and things like that. Those are all we can actually use stories to allow the machine learning model learn conversations and be better able to predict the dialog flow. All right, with all this information, I think we can go ahead now and actually implement the CLI based on the YAML spec that we initially defined. I will hopefully soon be releasing a code generator on GitHub to automate that process. And in terms of the implementation at a very high level, the workflow is pretty simple. Try the traditional route where the CLI parses the input from the terminal. And if there are no parsing issues, great, execute the command. But if the CLI is unable to parse the command or the options, then we invoke Rasa Obviously, behind the scenes, we are connecting our CLI to Rasa REST API and see if Rasa can understand the user text. And if so, great, Rasa will send you the intents, the entities that it identified as to what the commands, the subcommands options are. Again, it obviously depends on the Rasa model and your implementation. And so based on Rasa's output, we can then re-execute the command. Let's take a look at the CLI in action. Let's see here. We're saying cube control. What is my default context? Cube control didn't know that because we tried to converse with it in natural text. But if we use our supercharged CLI, which is here just K, it was able to interact with Rasa, and Rasa told us what the user meant, and it was able to execute the specific command. Again, here, one more example, cube control, show my config. Cube control did not understand it, but our supercharged CLI would be able to, because it talks to Rasa. Rasa tells us what to do, and it was able to perfectly execute the command and show the user's current config. Pretty neat. Okay, now let's move on our fun, switch our focus to graphical user interfaces. Just like with supercharging command line interfaces, I believe we can provide an enhanced user experience by building graphical interfaces with conversational AI at the core. And in terms of supercharging graphical interfaces with conversational AI, it actually lets the user, for instance, slice and dice a large data set, tabular data, just by using natural text. Again, be able to expedite the user onboarding process. And I think it will allow us to ask or instruct the system to make UI state changes. Examples would be like refreshing graphs, pagination, and filtering of tables, and things like that. So here's this screen capture of a trading marketplace UI that has this is an example of a supercharged graphical user interface. So it has conversational AI, Rasa at its core. So in addition to providing UI components like buttons and drop-downs, it also provides a chat window, as you can see on the left side here. So the user can simply start asking the UI what they want. In this example, the user is interested in Bitcoin. So based on the user provided message, the interface was refreshed to show the live Bitcoin ticker. So you can see that the message to the user was, got it, look to the right, I'm now showing the Bitcoin ticker and some more relevant information for you. I think this user experience can be pushed further by integrating voice into the mix. So voice to text and pass the text to Rasa, refresh the UI. So you can see there are multiple ways to really enhance the user experience. Continuing along with our example here, as you can see, the user asked a follow-up question to get the trend in price. Notice that the UI, rather the underlying conversational AI engine, knows that the context, even the context is Bitcoin, even though that was not specifically mentioned by the user, right? The user just said, tell me if it is trending upwards. Obviously, it in this context refers to Bitcoin, and so Rasa was able to gather that. I think that's pretty neat. Now, as for the implementation, just like with CLIs, we can use Rasa to describe the intents, the entities, provide real conversations or sample user conversations. And once that's done, we build the graphical user interface part using JavaScript or whatever you fancy, and then you interact with Rasa in order to figure out the user's intention or what the user is asking for, and then based on that, make state changes in the graphical interface, provide user with real good information. So to recap, I talked about conversational AI. I then talked about how we can supercharge CLIs and graphical user interfaces by using Rasa and conversational AI. I tend to call such interfaces, like I mentioned before, instructional dialog interfaces. I then walked you through these steps to build a CLI with Rasa at its core, demoed a prototype, and then I also talked about how we can do the same thing or a similar thing by supercharging graphical user interfaces. All right, Thank you for tuning in. Stay safe, you all.